Welcome to ZoomInData. Hello everyone. Thank you for joining the 16th video in our extended Azure Logic Apps series. In this session, titled Performance Tuning and High Throughput Optimization Patterns, we will cover key performance bottlenecks in Logic Apps workflows and how to identify them. Advanced tuning techniques for reducing latency, increasing throughput, and handling large-scale processing. High-throughput design patterns including concurrency control, batching, stateless workflows, and scaling strategies. Monitoring tools and metrics to measure and maintain optimal performance. 2026 edition. Performance tuning is critical when your workflows process thousands or millions of runs daily. Small optimizations can save significant cost and time. If you find this content valuable, please subscribe to ZoomInData and enable notifications to stay updated. Let us begin. What are the most common performance bottlenecks in Azure Logic Apps? Frequent polling triggers creating unnecessary executions when no events occur. High latency managed connectors due to external API throttling or network delays. Sequential processing of large arrays or batches without concurrency. Excessive run history storage and long retention periods increasing I/O overhead. How do you identify performance issues using Azure Monitor? Monitor key metrics: run duration, average and percentile, failed runs, throttled requests, and trigger latency. Use Azure Monitor dashboards to visualize trends over time, example spikes during peak hours. Query log analytics for slow actions. Azure Diagnostics, where category equals, workflow runtime, summarize AVG, duration ems_d, by action name_s. What is the impact of trigger type on performance? Polling triggers, example, recurrence, when a file is added, introduce latency equal to the polling interval and consume executions even when idle. Webhook, push triggers, example, HTTP request, event grid, provide near real-time activation and zero idle executions. Best practice. Always prefer webhook triggers for high throughput or low latency scenarios. How does concurrency control improve throughput? In for each loops, enable concurrency, default 20, max 50, to process array items in parallel instead of sequentially. Set a reasonable limit to avoid overwhelming downstream systems, example, 10 to 20 for API calls. Concurrency dramatically reduces total run duration for batch processing. What is split-on and how does it help with high-volume triggers? Split-on automatically debatches arrays from trigger outputs, creating separate workflow instances for each item. This enables true parallel processing of bulk events, example, thousands of new records. Use it on triggers like when a message is received in a queue or HTTP with array payloads. Explain the performance advantages of stateless workflows in standard model. Stateless workflows do not persist run history or state, resulting in faster execution and lower resource consumption. They are ideal for high throughput, fire and forget scenarios, example, real-time event processing. Trade-off: no resumability, use only when persistence is not required. How do you optimize managed connector performance? Prefer built-in connectors, HTTP, data operations, over managed ones for speed and no throttling risk. Batch connector calls where possible, example, batch insert into SQL. Monitor connector throttling and add delays, retries when hitting provider limits. What role does the standard model play in high-throughput scenarios? Standard provides dedicated resources, vCPU, memory, with higher execution limits and no multi-tenant contention. Unlimited built-in operations and better concurrency control compared to consumption. Use standard when predictable high volume is expected. Example: 100,000 plus runs per day. How do you use batching and aggregation to improve performance? Collect multiple items using until or for each. Compose arrays. Send in a single connector call. Example: batch SQL insert. Reduces API calls and network overhead significantly. What are best practices for handling large files and payloads? Avoid loading entire files into memory. Use chunking actions, new in 2026, to process in parts. Store large payloads in blob storage and pass references instead of content. Use streaming where supported. Example: HTTP actions with chunked transfer. How do you tune retry policies for better performance? Configure retries only on transient errors. Example: 429, 503, with exponential backoff. Set reasonable max retries, 4 to 6, to avoid long delays. Combine with circuit breaker patterns, custom logic to pause on repeated failures. What monitoring metrics are most important for performance tuning? Run duration, P50, P90, P99, to detect slow workflows. Throttled requests and action latency to identify bottlenecks. Trigger frequency versus successful runs to spot polling waste. How does Application Insights help with performance analysis? Standard provides end-to-end transaction tracing across actions, connectors, and external dependencies. Shows performance waterfalls, dependency failures, and slow operations. Enables custom metrics for workflow-specific KPIs. What are advanced scaling patterns for ultra-high throughput? Distribute load across multiple Logic Apps instances using event grid fan-out. Use Azure functions for compute-heavy steps inside workflows. Implement queue-based processing with service bus for back pressure handling. How do you avoid common performance pitfalls? Never use short polling intervals without throttling protection. Limit parallel branches in high latency scenarios to prevent resource exhaustion. Regularly review run history retention. Long retention slows performance. What are the latest performance enhancements? As of January 2026. Improved concurrency limits and auto-scaling in standard hosting plans. Native chunking and streaming actions for large document processing. Enhanced throttling detection and automatic backoff in managed connectors. How do you measure and benchmark performance improvements? Baseline current average, P99 duration using Azure Monitor. Apply one optimization at a time. Example: concurrency, batching, and compare new metrics. Use synthetic load testing, example, via Azure load testing, for controlled benchmarks. What is the impact of loops on performance and how to optimize them? Sequential loops can create long-running workflows and high latency. Enable concurrency, 10 to 50, for parallel processing of independent items. Use until loops sparingly. Prefer for each with early exit conditions. How do you optimize AI-integrated workflows for performance? Cache frequent embeddings, responses using Redis or Cosmos DB. Use smaller models, example, GPT-4o Mini, for simple tasks. Batch multiple prompts into a single OpenAI call where possible. What role does hosting model choice play in performance? Consumption is fine for moderate throughput but suffers from multi-tenant contention. Standard offers predictable performance, higher limits, and dedicated compute. Switch to standard when P99 duration exceeds SLA or throttling occurs frequently. How do you use Azure Advisor for performance recommendations? Azure Advisor analyzes Logic Apps and suggests optimizations. Example: shorter retention, concurrency tweaks. It identifies underutilized resources and potential cost, performance trade-offs. Review recommendations weekly in production environments. Why is performance tuning knowledge critical for interviews? Interviewers ask, how would you handle 100,000 daily runs without throttling? Demonstrates real-world production thinking beyond basic workflow creation. Key for enterprise roles where scale and reliability are non-negotiable. What is your step-by-step performance tuning checklist? Measure baseline, run duration, throughput, throttling rate. Optimize triggers. Switch to webhook, increase intervals. Enable concurrency, batching, for each, split on, aggregate calls. Monitor and iterate. Use Azure Monitor plus test after each change. How do you balance performance with cost? Concurrency increases throughput but raises connector costs. Find sweet spot. Use stateless workflows and short retention to reduce storage bills. Prefer standard for high volume to avoid per execution spikes. What final advice would you give for achieving high throughput mastery? Always design for scale from day one. Start with webhook triggers and concurrency. Monitor continuously with Azure Monitor alerts and dashboards. Test at scale early, load testing, and document every optimization for your team. Thank you for watching this detailed session on performance tuning and high throughput optimization patterns in Azure Logic Apps. If you found this video helpful, please like, share, and subscribe to ZoomInData. More advanced Azure Logic Apps content is coming soon. See you in the next video.